Hey everyone, it's Mr. Canfield. We're going to do part 2 of chapter 19, function analysis. All right, and we're going to start with everybody's favorite problem that's going to require quotient rule to do the derivative. Hooray, f of x is equal to x minus 2 over x plus 6. So this is not as dark as I was hoping it to be. Here, I think this will work. So if I'm trying to take the derivative of f of x equal to x minus 2 over x plus 6, well, quotient rule dictates that we're going to have a subtraction in the middle. It's going to be two things, two more things, and then the bottom squared, right? So remember, we're going to take the derivative of the top first, and fortunately for us, that's just 1. The derivative of the bottom, oh wait, we keep the bottom alone, x plus 6. Then we'll take the derivative of the bottom, which is also just 1. And we leave the top alone. So good old quotient rule. So that's our f prime. So when I do that, I get x plus 6. Now, if I'm careful and distribute this negative here, I get minus x plus 2. Just remember that this x minus 2 and this 1 here, we could multiply that by 1 and then distribute the negative. Remember that that's the 1 doesn't affect anything, doesn't change anything. So interestingly, x plus 6 squared, we wind up getting the x's canceling. We wind up getting 8 over x plus 6 squared is equal to f prime of x. And so if I were to set this equal to 0 and try to solve it, what you're going to find is that to set a fraction equal to 0, the idea that we're looking for is, hey, do I ever have a number on the bottom and a 0 on the top? If I do, that's equal to 0. Let's think about this the other way around. What would happen if we had a number on the top and a 0 on the bottom? This is an undefined situation, and so we can just write a big nope, we can't do that. And so that's actually a DNE, so does not exist. So because of that, the top here, does 8 ever equal 0? No. That means that there are no zeros of this, but there is a place where it's undefined, and that is when x equals negative 6. So x equals negative 6 is going to be our critical number, or critical point, or critical value. Because remember, critical numbers come from when the derivative is either 0 or nope. I mean, we're undefined. So if I set up my sign chart, the only critical number I have is negative 6. So now I'm dealing with 8 over x plus 6 squared. So pick any number less than negative 6 that you want. It doesn't matter. Negative 1,000, who cares? 8 over negative something squared doesn't matter. We're going to end up with a positive. And then here, we're going to have an undefined, so I'm going to write DNE. And then over here, pick a number bigger than negative 6. So I'll pick 0. It's nice and easy. That's going to be 8 over 30. It's a positive 6. 8 over 36 is positive. Did I say positive 6? Whatever. It's going to be a positive. Okay. So if you think about the slope of this, DNE is going to produce, in this situation, it's going to produce an asymptote. So we have a positive slope. That's going to look like this. How do I have a positive slope and then go to an asymptote? Well, I have to go like, whoop, like that, right? How do I then come out of an asymptote and still have a positive slope? Remember, it's got to be rising. So that's going to look like this. And I can't tell by this if it's going to have some sort of horizontal asymptote. I could go back to the original and look at that and go, oh, right. If I'm doing my horizontal asymptote rules, I know that this is going to 1. And so what I really should have drawn is something where here's our asymptote, and then here's a horizontal asymptote. Not that we need all of this right now. That's not what this unit is asking us about or to think about, but oops, wrong way. Oh, wow, I drew it totally the wrong way. Sorry, autopilot. So, all right. Well, now that I drew that, so we're going to have it like a negative 6, and so it's going to be going up and then coming up like that. This is going to be one of those kinds of graphs. We don't need all that, but if I'm talking about when this is increasing, I could say f of x is increasing on the interval negative infinity, I can't say it's increasing forever, because at -6, it's broken. So I have to say from negative infinity all the way up to 6, and then again from -6 all the way to infinity. So at -6, it's not doing either. At -6, nothing's happening. Something weird's happening there. But everywhere else, it's increasing. So hope that was helpful. I'm going to do the next one as well. Let's look at number 4. I'm just going to try to go through all of these. I was kind of pressed for time in the last video, so I have a little bit more freedom now. I'm going to try to go quickly because I want to get through everything in a decent amount of time. So if I'm trying to find increasing and decreasing, we'll do the same thing that we did before, right? We'll take the derivative. So this time, so leaving that alone, leave that alone, take the derivative, and then have the bottom squared. Okay, so this time when I take the derivative of the numerator, I get 2x. The denominator, I get, the 4 goes away, so it's just 2x again. So if I am trying to set this equal to 0, because that's the derivative, personally, the way that I like to think about that is anything that makes the bottom equal to 0 is going to be one of our critical points. It's going to be one of our does not exist places, but it's still worth knowing. And so I take x squared minus 4 and I set it equal to 0. I can add the 4 to both sides and take the square root of both sides and get 2 like a lot of you do. But we're wrong. You know that we're wrong. You got to think a little bit more about it. When we take the square root of both sides, remember, 2 is not the only answer. 2 times 2 is 4. But so is -2. So 2 and -2 are both answers. It's important for us to have both of them. So then I'm going to set the numerator equal to 0, and I don't really feel like foiling all this out. I would rather see if I can do some factoring and make life easier. So we did this trick in class last time. The AP exam loves to have questions like this that have really nice factoring that we can pull out, because these both have a 2x, and if I were to pull a 2x out of these, then what's left, because it's going to go away here and it's going to go away there, we're going to just be left with x squared minus 4 minus x squared. And if you're thinking clearly about this, those cancel, and we wind up getting 2x times -4, or just -8x. So you could have left it factored like that, but all this, you could do all the work too. So let me just kind of prove myself. If I FOIL stuff out, I get 2x cubed minus 8x, and then I get minus 2x cubed. Okay, so maybe I wasn't as slick as I thought I was. Maybe this was a much faster way to do it. Whatever. Good for you. You're better at this than me. Okay. So anyway, what's the place that this equals 0? Well, it's when x is equal to 0. So my 3 critical numbers are 2, -2, and 0. So I'm gonna show you the alternate way that we do this. So we'll use our, let's see, we got -2, 0, 2, and then instead of going underneath, people will go above and they'll do like, okay, so let me look at f prime. So here's the interesting thing. F prime of this is just the top is -8x, so it's -8x over x squared minus 4 squared. Right, and that's going to be f prime. So if I pick a number less than -2, like -3, and I try plugging it in, I get a positive on the top, and I get you know, think about this a little bit more. Plug in anything you want here. Square it. It doesn't matter what happens here, it's going to wind up being positive. So the bottom's going to be positive unless it's 0. So because of that, we know that we're going to have a positive on the bottom. And so over here, f prime is positive. At -2, it does not exist. And then in between -2 and 0, well, if we try that, it's still positive. At 0, it's actually 0 because of the top. That was what we got. And then if we go between 0 and 2 and plug that in, the bottom's still positive, but the top is going to be negative. And then 2 is going to be, that's another one of our DNEs. So guessing, before I look at that, guessing it went plus and then plus. I'm guessing it's going to go minus and minus. That's my guess. And if I look at this, plugging in something greater than 2, and the top turns into a negative number, but the bottom stays positive. So sure enough. So the way that we could look at this, we are looking at asymptotes for these, since there was no canceling. So the original f of x is going to be like going up and then coming up, but at 0 it's going to flatten out. And then between 0 and 2 it's going to start going down again. And then it keeps coming down though. So what's going to happen is it's going to come down from the top like that. And so if you paid enough attention at the beginning of the question to what the horizontal asymptote would be, it's going to be 1. So I know this one also is going to have a horizontal asymptote of 1, and I probably butchered what this looks like, but you can see that there's only one place that's going to have a relative extrema here, which was a bump, right? A min or a max. We sometimes call them a local min or local max, and it's that dot right there. And so the key things that we have here is that the derivative was equal to 0, and we changed sign. A change in sign around one of our critical numbers of the derivative will show us, oh, so it was going up, then it was going down, or it was going down and then it was going up. That's how we know that we're going to get some kind of relative extrema. So that's leading into where we're going in the next question, I believe. So to those of you that watch most of the stuff I put out for this class, I really could use your help. You don't have to leave a comment on the video or anything. If you could just tell me in real life, that's fine. I know some of you like to participate in the comments section, so if you want to do that, feel free. But I want to know if me doing it on paper like this is more helpful, or in the book is more helpful, or if it's fine, like if it doesn't matter to you, like that'd be great too. I try to keep these as low effort as possible for myself, since I'm churning out so many of them. But I want them to be helpful. So whatever's going to be more helpful, either way, there's not a lot of effort one way or the other for me, like writing it in the book or writing it on separate paper or anything like that. If there would be something that I could do that would increase the effectiveness for you, like I'd love to know. So, all right. 5 through 8 ask us to find the relative extrema. We essentially do what we just did. We take the derivative. We set it equal to 0, and we set it equal to does not exist. We find the critical points. We do a sign chart, and we analyze the sign chart. So the only other thing that we have to do is we have to find out what this point actually is, the xy of that point. So that's what we're going to do in 5 through 8. All right. Question number 5. It says find the relative extrema of f of x is equal to 5x to the 4th minus 20x squared. All right, so the derivative of this is thankfully simple, 20x cubed minus 40x. So then when we set this equal to 0, remember, I don't have to set this to DNE, it's a polynomial. So polynomials are never DNE. Polynomials exist everywhere for all x values. When I set this equal to 0, I'll be able to factor a 20 out of both of them and an x. So I'll factor a 20 and an x out, and if we do that, then we get x squared left in this first term minus a 2 in the other one. All right, so if we go and we try to find the relative extrema, the critical points, then I gotta set this equal to 0. set this equal to 0, and solve them both. So solving this first one, hopefully not too hard. You divide by 20, you get x is equal to 0. This one, we get x squared is equal to 2 when we add the 2 to both sides. And then when we square root both sides, remember we're going to get two answers. We get plus or minus square root of 2. All right, so let's drop our sign chart in here. I'll go back to the more traditional one that we do in class. So I got 20x and then x squared minus 2, okay. And then I got negative root 2, and I have 0, and I have positive root 2. And then down here, so what's f prime doing? Okay. So let's see, I'll try a number to the left of negative root 2. I'll try negative 1,000 just because, you know, why not? And so I get a negative here. Now a negative squared is going to turn into a positive, and so when we subtract 2 from it, we're going to get a positive. So a positive and a negative multiplied, then we know f prime is going to be a negative. Similarly in here, well, we wind up getting a 0 here, and we get a negative, which is a 0. And then in between, I'll just pick negative 1, because the square root of 2 is just a little bit to the left of negative 1. So I'll try negative 1, and I get a negative here. And this time when we square it, it's going to be less than 2. So because it's going to be, you know, if I tried negative 1, I mean, we square it, and we get something less than 2. So that's going to still be negative. I mean, it's going to be negative. Okay, brain broke. All right, negative times a negative is a positive. Okay, then over here, I'll plug in 0, and I get 0 and negative, and then that's going to be 0. Remember that all of this that I'm doing, I'm kind of showing some of the most work that we would show for these. You can certainly do this with a lot less work than this, or a lot less thinking than this. I'm doing the way that works when we need things more explicitly spelled out. So here, I plug in like 1 or whatever, I get a positive and then a negative. So that gives me a negative. And then when we plug in root 2, we get a 0 here, and then it doesn't matter, but it's a positive. And then plug in something after root 2. So I could plug in a billion, I get a positive. A billion squared minus 2 is still positive. So then we get a positive. All right. So what does this do to f of x? We know that negative slopes mean that f of x is falling, right? So falling, flat. Rising, flat. Falling, flat. Rising. So almost looks like a sequence of movements to put in like a fighting game or something. Just have to, you know, press B at the end or something. Okay, so we know it's going to be flat here. It's going to be flat here. It's going to be flat here. So it's going down, flattens out, goes back up, flattens out, goes down, flattens up, goes back up. So, you know, that's here, that's here, that's here. And so because of that, I know that this is going to be a relative min, and this is also going to be a relative min. And this is going to be a relative max. So the way that we figure out what those points are, so we can say relative min at negative root 2, comma, whatever the y value is, and I plug in negative root 2. And then same thing for positive root 2, comma, whatever we get. And then we're going to get relative max at at 0, comma, whatever we get. So now we just have to go back to f of x and find my y values, right? So negative root 2, I'll plug it in, and I'm going to do this by hand just because I don't have my calculator with me. So 5 times negative root 2 to the 4th minus 20 times negative root 2 to the 2nd. And you might notice that if this was negative or positive, it wouldn't matter, because so an even power is going to cancel out the negative. So this is going to be 5 times, now root 2 to the 4th is the same idea as saying like square it and then square it again. So if we square it once, it turns into 2, and we square it again, it turns into 4. And then here, that's going to be 20 times square root of 2 squared is is just 2, so it's going to be minus 40. So 20 minus 40, we get negative 20. So I know I'm going to have relative mins at root 2, comma, negative 20, and negative root 2, comma, negative 20. So those will both be negative 20s. And then 0, hardest number ever to plug in 0 there, and we get 0. So what I'm able to do now is I'm able to actually plot these points and then draw the graph the way it's supposed to look. So it's cool stuff. Let's see what's next. I'm going to try something. I'm not going to do the next 3 examples. I'm just going to move on to the next topic. You know what? No, this is the end of new ideas, but I'll do the rest of this, and then I'll do the next topic in the next video. We'll make that part 3. Concavity is kind of its own little game to think about. So we'll probably have 2 more videos in this section, in all honesty. But looking at probably 1 more class on it. Probably have a class and a half, including the stuff we did today. Okay, anyway, so again, if you think you got it, I'd say definitely go and make sure you got the homework taken care of. So we're going to find the relative extrema of this one. It's almost the same question, but this time it's x cubed. So when we take the derivative and we get our 20x cubed, that's the same, but this time it's going to be minus 60x squared. Finding its zeros, it's not crazy different. We're going to factor out a 20 and an x squared this time, leaving x minus 3. And so the zeros here, well, we wind up getting a 0 of 0 and a 0 of 3. It's a polynomial, so there's no DNEs ever. And so when we go in and analyze this, I'll do the wiggle graph this time. I'll do it the different way. So we got 0 here. Sorry, we have 0 here. We have 3 here. So we have 0 and we have 0. When we plug it in, and in between, if I pick someone in between 0 and 3, remember this is f prime. Just to remind myself, this is f prime of x. If I pick between 0 and 3, like a 1, I get a positive times a negative, so it's going to be a negative. And then if I try something greater than 3, like 1,000, then we get positive and a positive, so it's positives. And then if I pick something less, then it's positive and negative, and so it's negative over here. And so what we wind up having in this situation, what f looks like is f is falling. It flat. Ugh. All right, let me draw it in red, and maybe I won't mess up. So f is going to be falling, flatten out at 0, and then wait, it doesn't say it comes back up. It says it goes back down, and then flattens out here again, and then starts going up. So it is actually going to have 1 max or min. It's going to have a relative min at x equals 3, and so that's going to be at 3, comma, and I have to go back to the original and plug it in. So if I plug that in, 5 times 3 to the 4th minus 20 times 3 cubed. Easy math, right? 3 to the 4th is 81, so 5 times 81 minus 20 times, super easy, 27. I'm totally flexing and faking right now. If you don't have those memorized, I wouldn't know how to do them quickly. Like, you just kind of have to figure them out. 5 times 81, well, it's going to be 5 times 80 is 400 plus 5 times 1. So 400 plus 5, so 405. 20 times 27, that's not as simple, but this is 2 times 10 times 297. So I could multiply those in any order, so I'll do the 2 times the 27 first and get 54, tack the 0 on 540. So 405 minus 540. All right, if I did 540 minus 405, that's easier for my brain. So 40 minus 5 is 35, right? Oh, no, careful. So this turns into a 9, a 10, this turns into a 10, this is 5, this is 3. I'm silly, yep, it is 135. Hee. Okay. Sorry, I'm gonna blame me being tired, but I just made a silly mistake. Okay, so I got negative 135 since it's not 540 minus 405. Okay, well, that's a nice simple y value there. 3 comma negative 135. No big deal. Oh yeah, I go to that point all the time. All right, let's see what's next. Good old cosine, number 7. Oops, I wrote y equals. That's the same thing. Now, we should talk about why they mention this interval here. Stu's mentioning this interval because if we didn't put this, there's potentially an infinite number of maxes and mins. If you think about it, cosine goes like this. Whee! So if it does that, then it has peaks happening all the time. So if we restrict our domain to just say between 0 and 2 pi, then we're just looking for the zeros that happen on the unit circle. So simple enough. Since I wrote y, I'm sticking with y. I could have written f, which is what the problem said, but you know. The derivative of cosine is negative sine, and then the derivative of 1/2 x is plus 1/2. And so we are trying to say, hey, when does this equal 0 or undefined? And I just want to remind you, sine and cosine are always defined. The other trig functions could have issues. So I'll subtract the 1/2 from both sides and get negative 1/2 is equal to negative sine x, divide both sides by -1, or however you want to think about that. Sine of x is supposed to equal to 1/2, and so every time sine of x is equal to 1/2 on our unit circle, then those are the places that that we're going to plug in, because those are going to be our critical numbers. So just want to remind you that we could also use a triangle here and say, okay, sine of x is equal to 1/2. So if I call this x, 1/2, that's going to be SOHCAHTOA. So that's opposite over hypotenuse, 1/2. 1, 2, square root of 3, right? That's going to be our third side. So because of that, 1, 2, square root of 3, well, it's a 30, 60, 90 triangle. The 1 is across the street from a 30, the root 3 is across the street from 60, and the 2 is across the street from the 90. So because of that, I know this is a 30-degree angle, but I'm supposed to be all fancy and write it with pi's, so that's pi over 6 is equal to x. There's another one, though, and so we need to figure out another situation where we have a positive 1/2, and so that's, if that's this triangle here, the 1 and the 2, like that. If we think about our other possible scenarios, here's 1, here's 2, but that's falling. That's going to be -1. Over here, that's still going to be -1. But here, it's +1. So I would use this one. And so I need to think about that. 30 degrees off of the 180 over here is 150 degrees, or 5 pi over 6. And so those are our critical numbers. So now we can go in and check on a sine chart. So here's x. So negative sine x plus 1/2. That's my derivative that I'm dealing with. So I've got pi over 6, and I've got 5 pi over 6. So if I test a number to the left of pi over 6, the easiest one to test would be 0. So I get sine of 0, or negative sine of 0, which is still 0, plus 1/2, I get a positive here. At pi over 6, we should get a 0. In between pi over 6 and 5 pi over 6, well, that's between those two, so I'm going to pick pi over 2, because I know it's 1 there. So it says -1 plus 1/2. Well, that's going to be -1 then. At 5 pi over 6, I should get a 0. And then if I try something after that, but before 2 pi, any of them should give me the right thing. And if I'm thinking about this, remember that we had positive y values here, and then we have negative y values over here. So I can assume it's going to wind up being negative, but then it's negative sine x. But let's say sine of pi. Did I do something wrong? I feel like I did something wrong. No, I'm good. So sine of pi is 0 plus a half. We get a positive. So if we think about our original f of x, or y as I wrote it up there, it's going up, it's flattening out, it's coming down, it's flattening out, it's going up. And g, oh yeah, that's what the graph of sine looks like. Okay, so we know we're going to have a relative max at pi over 6 and a relative min at 5 pi over 6. So, cool. We just have to actually find the y coordinates now. So we can say relative max at pi over 6. So pi over 6, comma, something, min. I'm just writing REL, max REL min at 5 pi over 6, comma. So we'll have to find them. Okay, let's see. So if I plug pi over 6 into the original, cosine of pi over 6 is, well, we have it right here, right? Cosine would be adjacent over hypotenuse, so root 3 over 2. It's going to be root 3 over 2 plus 1/2 times pi over 6. Everyone's favorite, right? So that's just going to be, I don't have enough room to write that in big marker. That's going to be root 3 over 2 plus pi over 12. All right. Well, isn't that the most comfortable number ever in the world? Ever, forever, ever, ever. And then the other one, well, g. This time it's going to be negative because we're going off to the... So that was this one right here. The other one's over here. That means cosine is going to be negative because we're going off to the left. So it's going to be negative root 3 over 2 plus 1/2 times 5 pi over 6. So we get negative root 3 over 2 plus 5 pi over 12. There's a negative there. All right, cool. Last question. All right. Hey, so I don't know exactly how I'm going to edit this. I had a technical problem in the middle of number 8, but I also made a typo that resulted in a completely wrong problem. No. So I'm going to walk through everything again. So first things first, the derivative of everything. It's the first time for you. So I'm going to do the chain rule on this. So the first thing I do is I deal with the 2/3. So I bring that out front. So then I get 36 minus x squared. And then we'll subtract 1 from the exponent. So nothing major so far. And then we'll multiply by the derivative of the inside, which is negative 2x. Cool. So with this derivative, I've got a negative 2 and I've got a 3. And I can bring this 36 minus x squared to the negative 1/3. I can bring that down to the bottom and say it's 36 minus x squared to the regular 1/3. And this negative 2x, I can say times negative 2x. And when I said it was a typo, what happened was I dropped the x when I wrote this step, and it messes everything up. So doing that, the negative 2 times the negative 2x, we get 4x on top, and then we get 3 times 36 minus x squared to the 1/3. So if we're trying to find our critical numbers, our first one comes from the numerator, because when the numerator equals 0, the whole thing equals 0, right? So we get 0 is because 4x equals 0, and x has to be 0. And then down here, wow, another typo. I'm being a little careless right now. That should be 36. 36 minus x squared, well, okay. We're setting this equal to 0, and we're trying to solve it. We'll cube both sides, right? Cube 0. It's going to be super hard to do. Still 0. Then you can add x squared to both sides. You get 36 is equal to x squared. Take the square root. You get x is equal to plus or minus 6. And then cool. So we got 3 critical numbers, 3 critical points. Let's go and see what happens. So notice these 2 points are going to be places that are d and e in the derivative, but 6 and negative 6 are actually allowed in the original function. So you might actually have thought about this before. We actually could plug in 0, 6, and negative 6 to the original function and get points earlier on. So I could say 0, plug it in. When I plug it in, 36 to the 2/3, I actually don't know the cube root of 36 offhand. I'm guessing it's not nice. Yeah, okay, so it's something nasty. So I actually would I'm going to leave this as negative 36 to the 2/3. And then when I plug in 6, I get something nice. 6 turns this into 0, and so does negative 6. So we wind up getting 6, 0, and negative 6, 0, which those are great. But I don't know if these are maxes or mins. I just know there are places where it flattens out. And if you remember in the last problem, or not the last one, a couple problems ago, it like came down, but then kept going down. It didn't actually wind up rebounding. So this is where doing a chart is so helpful. So here's my negative 6, here's my 0, here's my 6. We can say f prime. And you might be like, you're doing it on the wrong side. You can do this however you want. This is what I feel like doing right now. So this one, at negative 6, it was undefined. So I'm going to draw a little asymptote to remind myself, and then an asymptote to remind myself like it's d and e, and then at 0, it was 0. So let me try something less than negative 6, like, I don't know, negative 100. 36 minus negative 100 squared. That's 36 minus a huge number. The cube root of a negative huge number is still a negative number. So that's going to be negative, but then the top is also negative, so the whole thing's positive. If I try something here, I'm going to try like negative 1. If I plug that in, the top turns into a negative, but the bottom stays positive, so the whole thing's negative. And then if I try something between 0 and 6, the same, oh no, it's different, because the top is positive then, and then the bottom is still positive, so it's positive. And then if I try something really, really big, then the top is positive and the bottom is negative. And so alternating often happens. So now if we think about what happens with f of x, the thing is that negative 6 and 6, it's defined. We have a point, but we don't have that. And so what is actually going on is this. This is the shape that it happens. That it happens. Now this is the shape that it makes. So let's do like negative 15. Let's see if that's enough. Did I really? I did. All right. So if I do this, is this enough? Yeah, okay. So we kind of see the shape that we're told here. We have a positive slope, an undefined slope at that point, a negative slope, a 0 slope, a positive slope, an undefined slope, and a negative slope. And so we'd have, these are both maxes. So we'd say that these are both maxes, and these are both. This one is a min. So cool. So again, hope this was helpful. The next video is going to cover concavity, which is, simply put, we're going to do all this stuff, but with the second derivative instead. And it's going to tell us something different. So see you in a minute, or never again. Bye.